Welcome to the session. Greeting of the day. In today's class, we are going to talk about the various applications of NDT techniques. Previously, we have seen in the last classes regarding the various types of NDT techniques. These are the various list of NDT techniques that we are using in our day-to-day life, such as visual testing, liquid filtrant, magnetic particle, eddy current, radiography, ultrasonic, acoustic emissions, and at last the infrared thermography. These top eight NDT techniques are useful for the various applications such as railways, aerospace, bridge constructions, fabrications, productions, a boiler plant repairing in services. So it is useful in a multi-way and all over manufacturing field. Therefore, the various applications and we are going to see one by one. On that, let me take first one as what are the various activities that can be done by this NDT methods. So we have studied in the previous lectures regarding the various types of NDT. In continuation with that, what is the usefulness of this NDT technique? Even though we know through NDT techniques we are going to do the various surface inspections and subsurface inspections, that we already know these things. But here, other than that, by doing this subsurface and by doing this surface inspections, what we manage, definitely the quality and the quantity, how much the mass production to be happen, and the effective cost management system that we do. So a few points I have added here as a benefits of this NDE. It means non-destructive evaluations. You see, verification of design quality. So at the preliminary stage itself, we want in the design stage itself, we multiple times we do inspections. In such a way, in the fabrications, we avoid the defects and discontinuities, because design stages we can able to do through softwares on paperworks. But when we are entering into the fabrication, it is manually material is consumed. Therefore, it is somehow takes more and more cost dependent. Therefore, through this ND method, non-destructive evaluation methods, we can able to do inspections at and verification at a design stage itself, and we can eliminate a lot of problems there. And also this, by doing this NDE methods, it is useful to certificate of manufacturing product, because we are justifying, we are inspecting and certificate this product is having zero defects, zero errors, we can able to certify. That is what our inspector's duty to. We have to certify, and that certification is valid. So verification and then it is certification. Then also assessments of product degradation, how long it takes to again this crack occurrence may happen, are always in service, in building, how far it will survive. So those things also we can able to judge whether the discontinuity is permissible in the range, permissible range or not, or otherwise it is not permissible, means we have to reject. So that a range of assessments we can able to, interpretations we can able to do with this. Effective repair or replacement during services. So effective repair by doing inspections, and if we finding the discontinuities, we may repair or we may replace during the service. Repairing is easy, but at the same time replacement is consumes more cost. That is why these three are working for us in the design itself and certification itself, all these things to reduce the cost. So it means effective repairing and replacement can be done when this NDT techniques used for inspection and finding the discontinuities. NDT has also been valuable tool to risk assessment based on the experience, how long it can able to work without any failures. So that's why it is a, if it is not judgeable, then it is based on the human risk. life factor will be affected. So those things are all to be keep in mind. This NDE brings out effective support in appreciating problems related to, that is a materials behavior, that is maybe the operations, that is maintenance, repairs and the specimens, repairs and replacements, ensuring the safety and reliability. The point what I told in the earlier slide, so the same points again I am concluding here. Verification, certifications, repairing, replacement, you see. So the similar points. So material behavior, how far it will behave up to this during the welding processes, how far the material behaves to this heat, at what temperature the crack occurs. All we have to identify and we should rectify also. So that we can able to find the materials behavior and what operations makes the discontinuity. So in the welding we can understand the TIG welding or SMAW are there. During high temperature the TIG tungsten electrode, there's a chance of breakage and tungsten may fall in the weld. So that is depend upon the operation current voltage parameters, high current. So those things and all operation management systems. So that way maintenance, repairing, replacements of the various systems are to be taken care by this NDT methods. This all can be done only if we are doing the inspection. So that is done by these 8 topmost NDT techniques. A number of railways components and assemblies are tested and evaluated using NDT methodology during manufacturing. For what purpose we are doing? We know cost effective and quality management. So that is what the freedom from the unacceptable defects and anomalies. So in NDTs, so see, discontinuities may be sometimes accepted when it is in this range of -5 to +5. So that range is accepted. Like some standards will be there. So that standards we are assuming, and above that it should not go. The crack length should not go, or otherwise the blowhole should not go. So we have to be free from that unacceptable range. Acceptable range is different. So that we sometimes we permit. The major components subjected to various NDE methods are in the railways. We are talking about take an example of the railways here. So we have to see one by one some of the various applications. So as of now we have taken here about the span of NDT activities in the railways. So in railways, what are the NDT methods we are using and where are the inspection has been done by these 8 methods or maybe 1 or 2 methods. See, we want to do the various inspection such as on wheels, maybe on axles of the railways, maybe on the bearings, maybe on the rails or tracks or bridges. So it is given here, or maybe the any welded joints of the railway tracks. So in all these cases we are understood that there's a chance of formation of discontinuity. Then the discontinuity may be in the range or maybe out of range. So those things and all depend upon the standards and those things and all depend upon the requirement of the customer. It means the supplier or purchaser. So see, first one, some example of wheels I have taken. So here some example of some wheels. So wheels are fixed on the axle. So we have see the axle, component axle, wheels are kept on the axle. The part of the wheel sitting on the rails and the track is called as a tire. This is something a definition we know that. Test methods commonly used in the fabrication of these wheels and in the railway components are, it means the inspection methods are maybe the visual, maybe the magnetic particle testing, maybe the liquid penetrant test, maybe the ultrasonic, and also the radiography. All these things we have seen in the previous modules of our lecture series. These methods are used to detect and evaluate the surface and the subsurface defects. So where the radiography and ultrasonic can able to go for the subsurface defects. We know this. And liquid penetrant testing and magnetic particle testing The liquid penetrant testing, matter particles and visual inspections are can able to do the surface inspections. So the both we can able to do on the surfaces if the surface crack is there, on subsurfaces if there is any porosities or inclusions are added there. So we don't know. Therefore, we are going for any of these methods to identify the railway parts inspections. These NDT methods are used to monitor the components to ensure their continuous usage. So if the crack occurs once, it cannot be it is not wasted. We should be repaired. We should reuse those things. That is what the owner of the company needs. And also easily we can't able to reject such a huge materials. It will be materials cost will be wasted. Therefore we want to rectify first the discontinuities, and also if it happens we want to try for repairing those things. Unless otherwise it is not possible to repair, then we move for the rejections. So see it is these components are subjected to various extreme conditions, such as maybe any of the service loads depend upon the loads on the railways. It acts maybe how much load applied and how much it is capability, depending upon that the crack may form. And also due to the wear fractures, maybe that wheel and the railway tracks are in friction, so the friction wear happens on the wheel definitely. So these are all consumes and it leads to some other error. So the high temperature and corrosion environment. So definitely when the friction is there, definitely temperature also increases, and also due to the environmental factors, definitely the corrosion will be happen. So these things are not maybe the coatings due to corrosion means again it's a stress concentration point. So all those things we have to manage, and it means we have to do inspection and then we have to repair or reject. See at the left image, I have shown some of the cracks on the various sections on the railway tracks. In-service difficulties. Next, we are going to talk about this in-service difficulties. You see, these in-service factors like service loads, as what we have discussed in the previous slide, service loads or frictional wears. These all things happens when the railway is running there on the track, such as service loads, maybe the friction wears, maybe the high temperature due to friction, or maybe the corrosion due to the weather conditions. So this factor lead to the initiation of the cracks, or maybe the failure of breakage of components, or gauge spreadings, or maybe the unacceptable residual stress on the components, and also the detonation of the material failures. So these are multiple chances are there. The crack, breakages, extension of the tracks. Therefore, if the extension due to high temperature, it elaborates slightly. So this extension makes a non-usage of the trains. So those things are all to be inspected frequently, and we have to rectify the problems. These damages, the above side cracks and breakage failures and material behaviors, these damages and deteriorations contributed to, see that is what train cannot run, maybe the leads in accidents, derailings, you see alignment problems will happen, or maybe the failure of the individual component or assemblies. Sometimes some components or assemblies or individual components may break. So such things all happening. See, to minimize and to occurrence of the accidents and deteriorations, we want to minimize this. Accidents should not happen, derailing should not happen. What we want to do for this? To minimize this occurrence of accidents and component assemblies, derailing conditions, we are doing these components and assemblies are subjected to the periodical NDT inspections. That is what I also told you. Frequently we have to go for inspections to the in-service location, and we have to check the tracks for every half a kilometer, however 1 kilometer we have to inspect the tracks. In such a way we can able to identify visual inspections, or maybe the eddy currents, or maybe the radiography, or maybe this multi-particle surface or subsurface inspections. Mainly ultrasonic will be helpful because it is all the railway tracks are connected. So we can keep on moving the component. It will be helpful to ultrasonic is the most important useful technique in the railways. So the component assemblies are subjected to NDT, NDT checks, and the records are maintained because these records we can use when we have done previous inspection, and we can able to trace the requirement when we have to do again. So this is one of the important scenarios to avoid those accidents. So some image I have shown you here. See, it is was the wheel and axles, or the original image also we have seen in the previous slides. So somewhere the load applied and the damping vibrations will form, the crack will generate therefore. So this is the one of the bridge, railway bridges. It is a photograph and assembly of the wheel and axles. Usually you see Usually, a specific test and evaluation techniques are developed for each situations depending on the part configurations. See, maybe it means each situations means whether the components are very large, or otherwise it is an assembled form, otherwise it is an individual specimen form. So individual specimen form we can able to take to the laboratory and we can do inspections. But at the same after assembly, always in the specimen is in the in-service conditions, the railway track continuously assembled. Then we can't able to take to the laboratories. At that time, we have to do in-service inspections, not the laboratory inspections. So for that, it depend upon the situations. We have to change the testing methods. So assembly conditions or maybe the test environment. Therefore, this all depend upon the sensitivity required by the acceptable standards. So how much it can be done. Based upon that, if we want to change the inspection methods. Inspection method may be, as I told, the top 8 methods: visual, magnetic particles, radiography, ultrasonic, and so on. In case the acceptance standards are not available, sometimes the standards may not be available. Only the breakage or failure or not failure. So in such conditions, the sufficient data needs to be generated, multiple inspection to be done. It means in coordination with the design and the maintenance agencies. So the maintenance agency, they will understand how much it can able to survive, what is the lifetime, what are the chances of defect occurrence there, what type of heat involvement will be there. So such due to with respect to such multiple scenarios, these standards are fixed and inspections are made in continuous with that. So currently the most important technique what we are using here for this railway inspections is ultrasonic method in pulse echo mode, which is most widely used NDT method. For those we are using a frequency using this range is 2 to 5 MHz for detection, location, and evaluation of the defects. So both in this ultrasonic method, both manual and automatic tests are available in the market, and as per the requirement and as per the sensitivity, as per the suitability to the reach that location, we can use maybe the manual method. If possible to reach there, we can use manual. If not possible to reach there, any automatic functions and robotic operated ultrasonic setup we can able to use. So ultrasonic velocity gives a good idea of material deteriorations and unacceptable residual stresses presence and absence. So this is the image how we are doing the inspection. See, some few images I have added here for our understanding the theory part. So this is the procedure of horn we have, and we are supplying the ultrasonic waves inside the specimen, and it comes back, and we detect. So here in this picture, in the right side, an employee is in-service inspection is doing through ultrasonic kit method. You see, if you are keenly watching there, here we have a camera and a stick with hands, and he is moving on the two tracks, one side track and on the track he is moving there. With respect to moving, he can able to pass the ultrasonic waves inside the specimen like this, like this, like this. He can send, and he can able to do the inspections. So this is one of the setup of ultrasonic machine. See, some few images I have made to look over for this inspections. See how they have the setup here, the cameras and the tracks and the long track of in-service inspections to find the discontinuities. See, the one of the picture here, a multiple breakage or damage has been occurred on the railway track. See how far it is broken. So multiple pieces is broken here, here, here. So somewhere here, some bulgings and the holes. So some various cracks are formed there. So we have to go for inspection. This is visually we can able to find, but even though subsurface inside possibilities also available. Those things also to be subjected to inspection. Some of the rails, casted rails. So after that we have to assemble and in service, and we have to maybe some fabrication testing, inspection, and in service inspection also to be done. All things to maintain quality, to avoid accidents, to avoid damages. So one of the pipe rail, it means here the pipe means here it is a small cracks, a blowhole like structure is available. We call as pipe in dissection rails. So see here, a bolted hole crack. The bolted hole, we have a crack here, cleanly visible. Through visible inspection itself, we can able to find these things. So also head and web separation. So here in dissection of the railway track, this head has been broken due to vibrations and damping efforts, damping forces. It is broken. But if we are not doing some visual inspections there on in a periodical way, there's a chance of rail accidents. So those things to be taken care properly. So see from some crack horizontal split head. This is the head. So this is the head called as a head, and this is called as a web. It is going too longer as a railway and totally like I sections. So on the head it is splitted. Therefore, it is called as horizontal split head. On there we have a crack, maybe due to vibrations. So here, see here, the defective weld part rail track has been entirely broken. When the next rail comes there, definitely it will derail from the track. Therefore, that and all we have to, for every rail continuity, we have to do inspection. Such much the inspection is most important. Otherwise, it is directly leads to the life threat factors. So see the corroded rails, because it is continuously subjected to the waters and the other corrosive environment, weather conditions, rains and all. Therefore, we are it is continuously corroded. If corroded means it is getting losing its strength factors. Somehow a visual crack on the rails, on the surface itself it is there. The surface itself it is there. We have to eliminate those things. See some of the ultrasonic rail testing automated setups. So similarly, not only the ultrasonic, sometimes the eddy current inspections also can be done. So in this picture, in the right side picture, they are using some eddy current testing on the tracks. It means we are using multiple inspection methodology based upon the requirements. So here they are using a magnetic particle inspection. At this point, they are using a magnetic particle inspections in this picture. Somehow it is an automated quality control system for rails. So length, dimensions, and the track maintenance all done through this some machinery equipments. So we can able to see in the left side image, I have a single flanged rail wheel, and the right side image I have a double flange railway. You see, and we have here the picture on the right side. I have a contact between the wheel and rail. So the wheel and the railway track. The friction wear occurs here. Definitely, the heat will generate dislocations at high point. This is the will be the high heat point. If it is heat is there, definitely crack. Otherwise, the metallurgical microstructural changes may happen, which leads to some brittle martensitic phase changes, and then the breakages. You see in some image ultrasonic inspections in the right side images, and then in the left side one ultrasonic testing on the wheel and axles they are doing. So ultrasonic inspection of the railway wheels for horizontal positions. We have this is the laboratory inspections, not in-service inspection. We are doing some laboratory. See, this is the wheel. Here the wheel, and we are doing some laboratory inspections on the same similar laboratory. That is a horizontal one. This is the vertical position inspection. Here it is available. The vertical. So of the few, this is magnetic particle testing, automated magnetic particle inspections, the components, similar some testing process. Here see, not only we have seen multiple techniques, magnetic particle, radiography, ultrasonic, eddy current. So at the last we have seen the thermographic inspections also. Likewise, vibrothermography, pulsed thermography, lock-in thermography is also some of the techniques we can use. Any one of the techniques we can use to identify the subsurface and surface cracks. See, when we are using the thermographic, see this image. Here we have taken a railway bridge. How far the temperature is involved over there? The dark zone here, the dark is lower temperature around 20 degree. It means this the water flow zones, otherwise the other non-steel zones are in the lower temperature. But at the same time, where the load is applied, where it is subjected to stress factors, or where the railway tracks are passing through, where the temperature, where the friction happens there we have a braid in colors. So here at the bottom we have the dark in color, at the top we have a bright in color. See, this is brighter color. So it is comparatively it is in the 32.7 degrees centigrade. But at the same time, when the railway is passing through, again some heat will be increases as due to friction. So somehow we can able to understand and we can able to take data how far it is before and after and during the railway passings. So here we can able to see these are the thermal images of railway overlines through which the power comes to the train. So some of the images it is showing some color bright and darker zones through which we can able to collect the data. The railway bridges. So up to now we have seen some few examples or few pictures how far it is useful. So the railway bridges. The railway bridges now as of now we have seen the tracks. On the railway tracks, what are the defect is occurring. At the same time, on the railway bridges also, it's a similar pattern of inspections should be done because without bridge, no tracks. Without tracks, no trains. So railway bridges are essential for continuous movement across the waterways and many other obstacles too. The role of NT in this regard is to support the maintenance of the bridge in service. Bridge in service conditions. Fabrication we can assemble, that is not a big deal, but in service it is subjected to loads. A lot of errors or a lot of discontinuities may form. A conventional as well as advanced methods like acoustic emissions are used to detect and monitor the corrosion and the cracks in the critical member of the bridges. Bridges are in the waveform of waterways. Therefore, a lot of chance of corrosions are available there. Therefore, it should be subjected to continuous inspections. For repairing and replacement of the members, ND is used to ensure the effective repairing. So that one of the important case. See, similarly, the health monitoring, I'm naming this as a health monitoring because on the railway tracks, continuous monitoring to be there. Now only we have seen some broken tracks and a crack and holes on the railway tracks. So such things to be monitored. We are naming this as health monitoring of railway tracks to avoid and reduce the derailments. Say the same word again and again it is coming. Derailments, accidents. Accidents of failure could be very expensive in terms of life threats and properties. So we have to do some inspections, continuous monitoring to be there. See, one more other method is available called as a hammer excitation method. So we can able to knock there on the tracks. Such a way we can able to understand through the sound what is coming back. Apart from visual and ultrasonic inspections, the instrumented hammer excitation is used as a tool for evaluation and monitoring the railway track structures. In this method, a signal analysis is used to examine the vibration responses. So we are using some vibration methods here for the structure to impact excitation. The impact excitation is converted in a frequency response functions and parameters like a damping and mode shapes are extracted for the health monitoring scenarios. So these are the cases we have seen. The summary: in today's class we have seen about few applications of NDT techniques in various scenarios like railways, aerospace, and that we have taken today's case study as railways, and we have done a lot of pictures on where the defect occurs and what are the type of inspection tools. Inspection tools may be the visual, maybe the ultrasonic, maybe the radiography, maybe the eddy current, maybe the magnetic particles, maybe the acoustic emissions, maybe the thermography also. So any methods we can able to use to find this railway inspections, to do these railway inspections. In upcoming classes we have to see about the other examples of nuclear, non-nuclear conditions also. The remaining part of the subjects we'll see you in the next session. Thank you.